have you ever stopped to think about the invisible force that powers pretty much everything around us? From the device you're watching this on right now, all the way to the incredible machines that can literally see inside the human body. Well, today we're diving into the amazing story of electromagnetism.
So, check this out. This is the inside of a hard drive. It's where we keep our photos, our music, our work. Our entire digital lives are packed onto these little spinning platters. But how on earth does that even work? How does a piece of metal hold so much information? The answer lies in a deep connection between electricity and magnetism, a connection that was found, believe it or not, completely by accident.
To really get this, we've got to jump in a time machine and go all the way back to the year 1820. We're heading to a lecture hall in Denmark, where a pretty standard classroom demonstration was about to go unexpectedly and brilliantly wrong.
So picture this. A physicist named Hans Christian Ørsted is giving a lecture. He turns on a battery to demonstrate something, and he notices that the needle on a compass sitting nearby twitches. Just a little flick. He had just stumbled onto the fundamental link between electricity and magnetism. This idea, Ørsted's principle, is the bedrock of everything we're talking about today. Run an electric current through a wire, and you create a magnetic field basically out of thin air.
Just stop and think about that for a second. It's wild. You flip a switch, and an invisible force field just appears. You can't see it, you can't touch it, but it's there, and you can control it. This was the massive aha moment that unlocked the power to create magnetism on command.
But this wasn't just some cool party trick for scientists. This discovery was the key that would unlock the next huge phase of the Industrial Revolution. It was the secret to turning electricity into powerful, controllable motion.
Okay, so scientists are smart, right? They figured out pretty fast that if one wire is good, a coil of wire is way better. By winding the wire up, they could concentrate that magnetic field and make it way more powerful. This thing is called a solenoid, and it's basically a bar magnet you can turn on and off with a simple switch.
And that right there, that was the key to the next huge leap forward. By putting one of these new controllable electromagnets inside the field of a regular permanent magnet, inventors created the basic blueprint for the DC motor.
So how does this actually make something move? Well, think of it like a little three-step dance. First, you send current into the wire loop, which turns it into a temporary magnet. Second, that brand new magnetic field starts pushing and pulling against the permanent magnets around it. And finally, this is the clever part, by switching the current's direction at just the right instant, that little push and pull becomes a powerful, non-stop rotation.
Okay, so now that we know how to make things spin on demand, let's bring it all the way back to where we started, that hard drive. How does this spinning thing help us store our data?
A hard drive is really a tiny, perfect masterpiece of electromagnetism, and it uses this principle in two genius ways. First, a tiny little electric motor, just like the one we talked about, spins those magnetic platters at thousands of RPM. And at the exact same time, a microscopic electromagnet hovers just nanometers above the surface, reading and writing your data by flipping the magnetic bits on that disk.
And the progress this one idea unlocked? It's just mind-blowing. The first commercial hard drive, back in the 60s, was the size of 2 refrigerators. It held a measly 5 megabytes and cost $50,000. Today, for about $100, you can hold literally millions of megabytes in the palm of your hand. That's progress.
But electromagnetism's bag of tricks is far from empty. This incredible force doesn't just store our memories, it's also given us a power that would have seemed like pure magic just a couple of generations ago. The ability to see inside the human body without making a single cut.
So you know about X-rays, right? They're great for looking at bones. And ultrasounds are good for some soft tissues. But MRI, magnetic resonance imaging, that's on a whole other level. It uses incredibly powerful magnetic fields to create these stunningly detailed pictures of both hard bone and soft tissue, and it does it all without any harmful radiation. Just look at this. This isn't a drawing. It's an actual image of a human brain, captured with a clarity that no other technology can really match. It gives doctors the ability to diagnose problems with unbelievable precision. It's a lifesaver.
Now, it's not all perfect, of course. This amazing technology has some serious drawbacks. The machines themselves are hugely expensive. The procedure can be super noisy and feel really confining, which is tough for people with claustrophobia. And most importantly, that magnet is so powerful. We're talking strong enough to lift a car, that anyone with a pacemaker or certain kinds of metal implants can't go anywhere near one.
It's just too dangerous.
All right, so we've seen how a little accidental twitch of a compass needle now powers our computers and helps save lives. But where are we going next? For that, we need to talk about a dream from over a century ago, from the brilliant mind of an inventor named Nikola Tesla.
Nikola Tesla, what a visionary. He dreamed of a world completely untangled from power grids. He built his famous Tesla coil, which, it could actually transmit electricity through the air. You could light up light bulbs from across the room. But the problem was, while it was super dramatic, it was also totally unpredictable and couldn't be used reliably.
And listen, Tesla wasn't thinking small here. He was absolutely convinced he could do this on a global scale. He wrote that he could send electrical energy anywhere on Earth without wires economically. His vision was for a world without limits.
So you might be asking, why are we talking about this 100-year-old idea now? Well, it all starts with one single massive number, 15 billion.
15 billion. That's how many batteries we think are thrown away around the world every single year, and only about 2% of them get recycled. Our constant need for portable power has a huge environmental price tag, as all those heavy metals leak out and poison our soil and water.
But here's the cool part. Scientists at MIT are picking up right where Tesla left off, but with a brilliant modern twist. They're using something called magnetic resonance. The best way to think about it is like an opera singer hitting a note that shatters a specific crystal glass. The energy only transfers when two things are tuned to the exact same frequency. This lets them beam power from a source to your device while completely and safely ignoring everything else, including you. And they've proved it works, safely lighting a 60-watt bulb from clear across a room.
And that really brings us full circle, doesn't it? A single accidental discovery gave us the ability to create motion on demand, to store basically all of human knowledge, and to peer inside ourselves to save lives. So if we can finally achieve Tesla's dream of safe, efficient, wireless power, just imagine what kind of world that same invisible force will build for us next.